Problem 11 is really an exercise in applying properties of exponents. Because we're given here an expression that has no addition or subtraction in it at all. Everything is multiplication and exponents, and division, I suppose. Right? So we just have to navigate how those things work together to try and simplify this expression that has powers of u, v, and w down into an expression that has as few of those powers as possible and in which all the exponents are positive. So what's the first thing, according to the order of operations, that you'd want to do to start cutting this problem down to size? What would be the first thing you want to think about? Yeah, let's look at the parentheses and ask, is there anything we can do inside the parentheses to make their quantities any simpler? Well, here I have a 3, a power of u, a power of v, and then downstairs a power of w. Those are 4 different things. So we can't simplify what's inside the parentheses here any. Likewise, for my second set of parentheses, I can't do anything inside of those parentheses either. So the parentheses here are not giving us anything we can do to make things simpler. So we're going to check p off of our list in the order of operations. What comes next? Exponents. So we can now actually look at the exponents that are being applied to the quantities in parentheses and start there. So that's going to put, for me at least, the target right squarely on this 3 that's attached to my first set of exponents. So what I want to do is raise everything inside this parentheses to the 3rd power. So now I'm going to draw those little arrows that everybody likes so much, where this 3, this power of 3, applies to each of the 4 factors inside the parentheses. This looks like a giant claw coming in and hitting each one of the powers. So then what I end up with is 3 to the power 3, and then u to the minus 2 to the power 3, and then v to the power 3, and downstairs w to the minus 2 to the power 3. I'm writing in here an intermediate step that I think a lot of people don't write in when they do problems like this, because I just want to be extra, I want to hit you over the head with this a little bit to make sure that we remember why it is we're about to do what we're about to do. Because now, I know how to raise 3 to the 3rd power. What is it? 27. 3 times 3 times 3. But how do I raise, I don't know, u to the minus 2 to the 3rd power? I can't exactly. I mean, I don't know what the value of u is, but how do the exponents change? So how can we decide which of the 2 operations, addition or multiplication, is appropriate for this case? Here's one way that I like to do it. What does it mean, again, to raise something to the 3rd power? Multiply it by itself. So often the margins in your scratch work, you can just kind of write out u to the minus 2 times u to the minus 2 times u to the minus 2. And now that's written out in this way, does that change your thinking about whether we should, or change your thinking about what this exponent should end up being? Yeah, right. Because if we were to treat this like it was multiplication of powers, then the exponents would add and give me negative 2 plus negative 2 plus negative 2. That would give me negative 6. Which is the clue that probably in the first place we could have and should have just multiplied the exponents. So raising a power to a power leads to multiplication of exponents. So u to the minus 6. Upstairs, v to the 3. Downstairs, how many w's am I going to have? Negative 6 also. Okay, great. So that takes care of the quantity that started out in parentheses over here. Now we just have to add back in the u to the 3, w to the minus 1 from over here. Carry it over here. U to the 3, w to the minus 1. And to help us out, we can always put a 1 in the denominator next to it, just to kind of give us a sense of how it's going to interact with this fraction that's over on the left. So now we have a little bit more algebra that we can do. Because upstairs in my fraction, I have a power of u coming from the left side and also a power of u coming from the right. So how do those 2 powers of u combine? U to the minus 6 times u to the 3. What happens with those exponents? Yeah, right. Add them, because they're multiplied. The powers are being multiplied, and so the exponents add. So we end up from this product with how many powers of u? U to the negative 3. And then my 27 carries over, and my w to the minus 1 carries over. Whoops, I forgot my v's. My v to the 3 carries over, w to the minus 1. And then downstairs, I still have w to the minus 6. All right, so we still have w's in two different places. So that's the last thing that we need to take care of before we can sort of get to the end game in this problem. So how do I handle a power of w divided by a power of w? Subtract. Division of powers, subtraction of exponents. And now here's another perfect place to make a sign error. We're going to end up with w to the -1 minus -6. Ugh. I'm going to restore everything else that we had in the fraction here. 7 u to the -3 v to the 3. 27 u to the -3 v to the 3. What's -1 minus -6? Positive 5, right, because it's w to the -1 plus 6. So at the end of that, we end up with w to the 5. And now restoring all the rest of my factors, u to the -3, v to the +3, w to the 5. Now the only thing we have left to do is rectify the fact that one of our powers still has a negative exponent. And that's something that I like to wait until the end of the problem to do. You can really do it at any time, but if you do it sort of early on, then you may end up getting negatives again later on in the problem, reappearing. So that's why I like to kind of wait until the very end, but your results may vary. What should I do with u to the -3 to turn the exponent from negative into positive? To turn a negative exponent into a positive one instead, we just have to change its role within the fraction. We need to move it from the numerator to the denominator or vice versa. In other words, trade multiplication for division. Because when I trade multiplication of a power for division by that power, I trade addition of its exponents for subtraction of its exponents, i.e., I change the sign of its exponent. So the u to the power -3, I can trade for a u to the power +3 just by moving to the denominator instead. So instead of u to the -3 upstairs, I'm going to write u to the +3 downstairs. Another note there is that the 27 in front of it stays where it is, because the order of operations says that the power 3 applies to the u here, and it doesn't actually apply to the 27 that's out in front, because it's being multiplied instead of being exponentiated. So sometimes a common error is that people will stick this 27 onto the u to the 3rd as it moves downstairs. Nope, just move the variable factor, because that's the part that has the power, the exponent of 3. So when we look at this answer and then scan our multiple choice options, it turns out that one of them in fact does, thankfully, line up with what we get at the end of this problem. And here it's choice E. Just to recap the first couple steps here, the first time that we dealt with exponents, it was because we were raising powers to powers. So u to the -2 raised to the power 3, that's why we multiplied exponents and got -6. Then after that, we added exponents because we were multiplying these two powers together. So u to the -6 times u to the 3. One of the cues to that is that you'll see the base twice, right? You see the u here twice showing up. And so that kind of should be a cue that, oh, I'm actually multiplying these powers, and so I should be adding the exponents. Whereas the cue for when to multiply exponents is often when you see parentheses, right? And the base is only repeated once, and it's a power of a power.